Hi everybody. In this talk, I will explain to you the meaning of the sacrificial architecture and how to implement it in modern web application. If you want to put it in other words, this talk explains how I learned to stop worrying and throw my code away. Before I start, I must warn you, I'm Italian, so I will move my hands a lot during the talk, but please be kind. Let's start with a question. What's the main purpose of Agile methodologies? Probably we all know the Agile Manifesto. We all know the 12 principles of the Agile Manifesto. And probably we all work with Agile methodology, with Scrum, with Kanban, retrospective, everything. But what's the main purpose? What's the ultimate goal of Agile methodologies? To put it in one sentence, I think that is to embrace change. Not just to welcome change, but to embrace it, to seek for change. Because through change, we can build a perfect software for our clients. We can build software that matches, as best as we can, our clients' needs. Let's go on with an experiment. Try to visualize in your head your average software architecture. Close your eyes and think about it. Think about your largest application and try to draw in your mind the architecture behind that software. Probably you are thinking about something like this, or better, something like this. Or if you are lucky enough, something like this. Generally, a software architecture is something that is hard to explain, hard to implement, hard to maintain. But there's one thing that they all have in common. They are hard to change. They are always hard to change. So I think that we are in this kind of situation. We have the Agile methodologies that says to us, we need to change, we need to get feedback, we need to change fast. But we have our software architects that say, no, we cannot change so fast because we choose this framework, we choose this architecture. So it seems that these are two concepts that cannot coexist. And remember that Batman always wins, every single time. But that's something that's always bothered me. People like him. Probably you know him. He is Martin Fowler. He wrote a lot of books. He wrote a book about UML, a book about refactoring, a book about enterprise application patterns, a very huge book about patterns. But it's also one of the men who signed the Agile Manifesto. So there must be a solution. If one of the most famous software architects of the world signed the Agile Manifesto, there must be a way to let the two things to coexist. And one of the solutions that I found during my years as a developer is the sacrificial architecture. This concept was thought by Martin Fowler himself. And to choose a sacrificial architecture means to accept now that after some time, you need to throw away what you are currently building. In other words, you need to design code that you can throw away. Think about it for a moment. This is quite a disruptive way of thinking, because we, as developers, usually, we design code that in our heads is meant to last years or decades, but we don't know the future, so we can't write code that can respond to changes in the future. And now, when I see an old piece of code that I don't write, that I don't understand, this is my expression every single time. I want to destroy code. In my opinion, there are two levels of abstraction in sacrificial architecture. The first one, the higher level, is on the whole project. This could be a useful approach if you are a startup, or if you work for a startup, or if your client is a startup. What's the goal of a startup? It's to hit the market as fast as possible, because you need feedback from your user. So sometimes you need to build the quick and dirty project just to hit the market. And probably that code is not a really good code, so you need to throw it away, everything. This is not a developer's problem, this is probably a business problem. But think about eBay. eBay has been rewritten as new 3 times. The first version was a Perl script. The second one, a C++ program, and then the last one in Java program. Because the code that they write in the 90s is not the same that they write now. The other kind of sacrificial architecture is the incremental one. Think about some very large business or enterprise application with years of development. You cannot throw it all away all at once, obviously, but you can build your application incrementally sacrificial. So you can destroy a part of your application, but your application will continue to work as nothing happened. Sacrificial architecture is not a pattern. You cannot just apply it to your project like MVC or like decorator, like command pattern. It's a way of thinking, it's a state of mind. So you need to apply it to your project, and every time it could be different. There's not cookbook in applying sacrificial architecture. It's also a way to accept technical debt. Usually, software architecture tend to erase technical debt. But in doing so, they are cages for our code. We cannot change code because of the architecture. So probably sometimes it's safer to accept some technical debt. But if you accept some technical debt on the architectural level, you need also to manage it on the feature level. So when you write a new feature in your application, you need to write it as best as you can. It must be, as much as possible, pixel perfect. Let's try now to apply this kind of architecture to web development. As I said before, there's no a simple way to do it because it's not a pattern. But what I can give to you is some hints to apply it to your new project in the future. Let's talk about modularity. A modular application, it's a good way to build a sacrificial architecture. This is a scheme from a modular application. You divide your application in modules, and every module is separated from the other. They do not share code or data. And this is a fully sacrificial architecture, because if we destroy a module because we don't need it anymore, or because we want to rewrite it in a different way, our application will continue to work as nothing happened. Module B and Module C will never know that Module A has been deleted. But this situation is an ideal one. You probably cannot achieve this in a real-life application. Probably you will end up with something like this. You have your 3 modules that don't know each other, but there's also a shared module, as you can see on the top bar, that lets you share data, like, for example, the logged user. The logged user is information that is needed to all of the module, and also shared code, like login or logout functions. But remember that all the code that you put in the shared module is not disposable anymore. Because if you destroy the shared module, your application will break instantly. So stay sharp. Because if your application starts to grow, probably you will end up in this situation with a huge shared module and very small featured module. Why? because you have some code in module A. After 6 months, you need to use the same code in module B. So what do? You put that code in shared module, and you use it on module B. And if you do that every single time that you have common code, you will end up in that situation. But in that situation, your code is not disposable anymore, so you are not sacrificial. So sometimes you need to accept code duplication in order to maintain your application disposable. And remember that the application is far cheaper than the rogue abstraction. It's a very important concept because sometimes we need abstraction that are cage for our business logic. Let's talk about frameworks. I'm not that kind of JavaScript developer that says, oh no, I hate frameworks, I have a new framework every week, I want to write everything in vanilla JavaScript. No, we need frameworks. We need frameworks because we need to keep our velocity high enough. But when you choose a framework for your application, choose it as you will need to change it after 6 months. Try this as an exercise. You choose to use Angular 1, for example, the mainstream framework for web development. But when you choose it, think about to change it after 6 months. Also, choose wisely what features you need to use of a framework. And when you choose, think about Indiana Jones. He made the right choice. Let's go on with an example. This is a classic standard Angular 1 application. In the first block, we have a service called getUser that depends on the HTTP client from Angular. It simply gets the user from the server, and it returns a promise. Then we use it on the controller, and probably we print that data on a table. It's not really important in this case. But let's try something slightly different. In this second example, we do the exactly same thing. But the first block now is standard ECMA6 code. We use export default to export the function to other modules, and we use fetch instead of HTTP Angular client. And then we use it on a controller in the same way. We just use import keyword instead of getUser dependency. What is changed? With almost the same code, we have half all of the technical depth of Angular. Because now our business logic is free from the framework. And we can dispose Angular. We can build the same application now with React with the smallest effort possible, because we freed our business logic from the framework. Remember that every time that you choose a framework, when you use it, design your way out of that framework. It's not mandatory to change framework after 6 months, but if you do this exercise, probably you will build a better application. Let's talk about UI components. I named this chapter UI components and not web components, because web components is a technology. It will become a standard. UI components is a state of mind. It's a way to design the view of your application. This is a scheme of a UI components application. As you can see, the application itself, it's a component formed by pages component. Simply, we show them one at a time if we have a single page application, but every page is a component itself, formed by smaller and smaller components. React, Polymer, Angular 2, they all think in this way. Let's focus for a moment on the relation between a parent and a child component. How can a parent component drive the behavior of a child component? with properties, usually. If I have an input component, I can change the value, attach an on-click handler, change the background color. So we have a lot of small pieces of code that work together through an API, because properties is a kind of API between parent and child controller. In other words, UI components are microservices for front-end development. They use the exact same core concept. Small pieces of code that talk with API that forms a complex application. And microservices sometimes could be a good way to build a good sacrificial application in the back-end world. So let's try to apply the same concept to the front-end development. Let's talk about how to separate logic. We have built our modular application, we have chosen our framework, we have defined our view with UI components. Now we have to write business logic. Let's think about where to put the code of your business logic. Let's try with a simple example. You have a standard React component this time. In the first block, we have simply a function that takes one parameter and does something. It's not really important what the function does. It's simply a function. Then we import that function and attach that function to the on-click handler of the component. So when we click on the button, the function is invoked. What happens if I destroy the first block of code? My application will break because the component doesn't find the function anymore. So let's try something different this time. Let's use an event bus. When I click on the button, I dispatch an action on the system with the same value. When I click on the button, I dispatch the action, something happened, and I pass exactly the same value as before. And on the business logic side, I just subscribe to that action and invoke the function. You can use an event bus, like in this example. You can use Redux, Flux, Mobix, RuhrJS. They all do the same thing. They separate the view from your business logic. And if you separate them, you can do this thing. If I destroy that code, this code will not break anymore. We simply have a button that does nothing. But your application will continue to live, so we can change it drastically, but our application will continue to work. And this is a very important thing in a very large project. I wanted to end my talk with a quote, and I choose this. The only correct way to write JavaScript is whatever you were not doing last week. It's a joke, obviously. It's a tweet from the Practical Dev account. But perhaps there's an hidden truth in this message. Because we, as a community, we don't know how we'll write JavaScript code in 2 years from now. I write a very different code from myself from 2 years ago. And probably I will, in 2 years in the future, I will write a very different code again. So we need to learn new things constantly. And to end the talk with a real quote this time, sacrificial architecture sometimes is the faster way to learn new things. I am Francesco Strazzullo. I work for Xstrategy in Italy. You can contact me with email, Twitter account, GitHub, or Medium. I don't have HQ. So thank you very much.